Welcome, ladies and gentlemen, here to the forum of the group exhibit Hydrogen, Fuel Cells and Batteries here on Hanover Fair 2015. You're very warm welcome to sit down here. You have some places left, have a drink on the house, coffee, tea, whatever you like, and discuss with us, because we have now a very interesting topic, which is called One Power Core, Many Opportunities, the Sunfire Partner Model for the Energy Industry. And I just tell you it's a little bit about SOFC and SOEC, and I'm very curious to talk with the CEO of Sunfire GmbH, Karl Berninghausen. Here he is. Please give him a hand. Mr. Berninghausen, good to have you here. Sit down. So you may participate whenever you like. Just raise your hand and ask your questions. If you have any question to Mr. Berninghausen, then you can participate in this discussion. All right, Mr. Berninghausen, I already told the audience that it's all about SOFC, SOEC. That's the power core in the end. That's your technology. What's so good about this technology?
It's a galvanic technology which converts electricity to chemical energy or the other way around. And the power core is a piece of hardware. It's a stack. It looks like a big gas battery, and it can be used as a fuel cell or as an electrolyzer.
It's both. Is it reversible then?
It's a reversible concept, and it can be used in both ways, which gives us a lot of opportunities.
That's very interesting. So, because I always learned, you either have an electrolyzer and you can run it efficiently as an electrolyzer, or you have a fuel cell system and run it efficiently. You can do both, really? Both efficiently?
Yeah, we can, and that has been tested successfully. It's only possible with the solid oxide technology. It's not possible with PEM or alkaline or others. And also people have been discussing this concept a lot during the last 10 or 15 years. And always due to material problems, it seemed to be an impossible thing to do. But now with the advanced technologies in material science, we are coming to a system which really runs, is efficient, and doesn't really degenerate too fast.
Is it in concept, or can you really prove it?
Well, we can prove it because we have already built it, and we have had tested it by, for example, IFA Institute in Aachen, and we are currently building the first larger system, 120 kilowatt electrolyzer mode for Boeing, and they have been, of course, evaluating this technology a lot. And we are also negotiating other big contracts with other partners. So it's becoming real.
Okay, so we have to talk a little bit about the solid oxide technology. What is special about it? You mentioned also alkaline and PEM. Well, what I know is PEM has some platinum in it, needs it as a catalyst normally, and solid oxide just needs ceramics. Is that right?
Yeah, it's basically simple materials. It's glass, steel and ceramics is what we have in the toilet, and glass we have in the windows, steel. So that's all simple and cheap materials, and the cost is only coming from the manufacturing process.
Which means call it the toilet fuel cell now.
That's exactly what it happens, yeah. And it's obvious that the manufacturing in small units in an early stage is expensive, and it's also obvious that as soon as we come to industrial scale production, it will be very cheap.
That is a big advantage of solid oxide in comparison to the PEM, because they need platinum, and if they need in larger scales more and more platinum, the platinum will probably rise in price and not fall down if you need more.
That's probably true, and the cost advantage of solid oxide is not only from the materials, it's also because it's a simple system, and it can use any sort of fuel like methane or even reformed diesel or other liquid fuels. And that is a big advantage because
PEM needs pure hydrogen. You don't need pure hydrogen, but you can
No.
take pure hydrogen.
we can, of course, also take pure hydrogen, but the PEM needs to have a pre-conversion of whatever hydrocarbons there are to pure hydrogen, and that is really what makes the system expensive. It's not only the stack, it's the system around it, which is so complex that it is more expensive technology. And I would say both technologies will have their markets, but
You have to say that, of course.
of course, I mean, we
You have
always
to be friendly.
well, I mean, we are friendly and we like to see other good people around us also being successful. And I think solid oxide will have its marketplace because of cost, of simplicity, of flexibility in use of fuels.
But it has disadvantages. We have
Oh,
to talk
yes.
about that because you have to run it on very high temperatures. I've heard 800 degrees is the normal temperature you run your SOECs on.
Yeah, that's of course one of the critical things we have, or one of the challenges. It's a high temperature system, which means we have to be very diligent in the production. It has to be a insulated system. But on the other hand, high temperature also has more use because the heat on a high temperature level is valuable and can be used for a variety of applications. So that is also
in
a strong point.
industrial applications, you always have the heat and you always blow it in the air. That's the normal way it goes, isn't it?
That's sometimes the case, and obviously everybody tries to avoid that. And we can use that heat to a certain degree.
How can you use that heat then?
If you look at an electrolyzer, what he does really is convert liquid water to a burnable gas, which is hydrogen. And in order to come there from water, which has no energy content, to hydrogen, you have to overcome two energy levels. One is from the liquid phase of the water to steam, and the second one is to rip apart the molecule and get the atoms of, or the hydrogen and the oxygen module. The energy needed for converting liquid to steam is only 16%, but still that's a large proportion, and we can use heat for that part of the job.
So let me get that correct. You use it as a fuel cell where you produce the heat and you don't put it to any houses or something like that. You just store the heat. So if you make the fuel cell reversible into an electrolyzer, you use the heat you produced as it was a fuel cell for the electrolyzing process. Did I get that right?
That was right, but I think in order to understand the whole concept, we have to clearly separate the different markets and applications. There is, of course, a lot of good applications which are strictly fuel cell. Yeah? This is for residential heating. There you only need heat and electricity. Then that's for automotive, that's for off-grid applications and so forth. But there are industrial applications where you can use both ways of this technology. And the driver is always the need for hydrogen or for fuel. And if somebody wants to convert renewable power from wind turbines or from solar and wants to bring this energy into the grid of fuel and make valuable renewable fuels, then he needs our technology. But as wind or solar are not always there, we also have to look at the times when there's a lack of power in the power grid. And then what happens then? We can't have a lot of conventional turbines or power plants who are just waiting there until this moment happens.
So that's the power to gas concept actually, what you're aiming at, isn't it? It's to bring the surplus power from the renewables into hydrogen.
Yeah, we bring surplus from renewables to not only hydrogen, but we can also bring it to liquid fuels. And the idea is
talk about that later.
Yeah, and the idea is to bring energy from one grid to another instead of storing it and bring it back to the same grid, like power stored somewhere and brought back to power. We just transfer the energy from one to the other.
But just let's stick to your reversible solid oxide technology. So I could use it as power to gas with an electrolyzer. And then when I need some extra power, I can switch the same device into a fuel cell and bring back the power to the grid, huh?
That's exactly what you can do. We would suggest to convert the excess power not to methane, not the strict power to gas. We would probably go for hydrogen, because hydrogen, pure hydrogen, can be sold at a higher value, or we would go directly to diesel or kerosene or wax. Always we bring power from where it's cheap to where it's expensive. Yeah? And gas is unfortunately not the best value that you can make out of power. But if we go the other way around, if we have a need of power, then we of course take the cheapest available power, and that's probably coming from the gas grid. So we bring the power, if we have enough power, preferably to fuel, and if we need power, we take it from the gas grid and bring it to the power grid.
Oh, I understand. Because you can use both. You can produce hydrogen. You could use hydrogen, but it's quite too expensive actually, and it's too wealthy. So you rather take the gas from the grid and produce the power that is needed at peak times. You need the power. Quite clever idea, I think. Just let's talk about this power to liquid thing. You have opened a device already in Dresden, which produces actually just from steam and electricity, renewables as possible, liquids. As you said, gasoline, diesel, naphtha, whatever.
Yeah, and that's what we use. Is our cooking recipe is based on water, electricity, and carbon dioxide. That's all things that we have in vast amounts, and it's not in any competition with food. We can make fuel out of it, and in Dresden we have commissioned the first plant, which is on an industrial scale, showing that this works.
So if this is true, we probably don't need to have to change our infrastructure to fueling station. We were just talking here at 11 o'clock with a group of high-level people who say, well, we need around 1,000 hydrogen filling stations in the farther future. You say, no, you don't need it. You can produce it by liquids.
I would never say we don't need it, because it's always a combination of the technologies that makes the change. And I think it's the market that should then select the best way. And there's probably applications where a pure hydrogen economy might work. Yeah, that's always if you have something which is going from one point to the other and back. There you can really work with hydrogen. Otherwise, if you have to distribute hydrogen over a very large surface, and the distribution and storage is what's difficult, then you probably come to fuel. It's always both.
Mr. Berninghausen, you can't solve all the problems of the world alone, no. So you need partners. So what can you provide? You have the SOFC and SOEC technology available. It's running. You can show it's working. Now you're looking for partners. What kind of partners?
We have defined a partnership concept which already works fine with large players all over the world. And that is based on the idea that there are already big partners or big system integrators using, for example, combustion engines or other conventional technologies to serve a need. It could be the boiler industry for residential heating. It could be the turbine or motor integrators for auxiliary power or off-grid power. And we are talking to those companies. We're always trying to find the biggest player in the specific market. And we offer them to replace conventional machines by fuel cell technology. In order to do that, they have first to do a lot of development and adaptation, and there we help. So the first partner service that we give is we do the prototype for the full system, because we have the system competence to do that. And then we hand over some knowledge, and in the end we would like to have a partnership where we supply the solid oxide technology pure. That's what we can do best. And our partner is doing the balance of plant, he's doing the installation, he's doing the service, and he owns the customer channel, which for us means we can be reduced to what we can do best, and we don't have to invest in customer channels and in all those very expensive and long-term investments. And we are not competitor to all the big players already, but we are their supporters. And that's a lot better.
Yeah. I think this can work with the solid oxide fuel cells because, well, there are already markets, like you mentioned already, distributed power, for instance, or the micro CHPs in houses. And so you can help those suppliers, of course, with your technology. But what's on the other side of the road, the SOECs, the electrolyzers? This is just a market which is developing and it's just on the edge of industrialization.
That's true. There is a different business model necessary. But if we look, for example, at something which is evolving right now, it's hydrogen fueling stations. Yeah, there's big Japanese companies who want to bring hydrogen cars to the market, so we need hydrogen fueling stations. A fueling station is an ideal application for a medium-sized electrolyzer, and we also suggest then not to just install an electrolyzer, but to install a reversible fuel cell, which can provide hydrogen for the cars, which can also take apart a little portion of hydrogen and bring it back to the power grid if necessary. So it's something like a dual function hydro station. Now the hydrogen station is something that has to do a lot with certification, safety, storage, and so forth. And that's something where we have the Air Liquides, the Lindes, and all the big players who already do that. Yeah, they can do a hydrogen station. So they would be our partners in that case, and we would supply them a novel advanced device which is called the reversible cell, and then they can integrate that into a fueling station. So that's the partner model again.
Very good. So are there any questions from your side? So please raise your hand if there are any questions from your side. I'll come with the microphone right to you. Well, the other thing is I would like to ask you, Mr. Berninghausen, about price, of course. And I often hear prices for electrolyzers. It's said, well, the price is per kilowatt, this and that. But I think that's kind of funny, isn't it? And so I pay a price for something then that I put into it. So the less I put into it, the better is it, isn't it?
That's true. You really don't want to buy a lot of consumption. You want to buy something that is producing a product. And if you, for example, have a given electrolyzer and that needs an enormous amount of electricity, then of course you can boost and say, I have bought an electrolyzer which is using a lot of electricity, but that's not really what you want. What you want is a lot of hydrogen.
Right.
And if
so
we
let's
compare
price for hydrogen, for a liter of hydrogen.
Yeah, the electrolyzer should be always measured in comparison to the hydrogen production. And then, of course, an efficient system like ours, we have an efficiency of above 90% if we convert electricity to hydrogen using some excess heat. That is a very high efficiency. Standard efficiency of technology like PEM or alkaline would be more 60. So we have 50% more efficiency, which is good for the installation because you don't need such a big machine in order to do the same job. And secondly, you will of course save a lot of cost during the operation.
But this works only if you use it reversible, also as a fuel cell, that you can have the heat and store the heat for the electrolysis process.
The heat can come from any source. And of course, if we do reversible, we can create our own heat in the fuel cell mode. But also, we have a lot of environments where there's heat available, and it doesn't need to be heat on a 800-degree level. It needs just heat that can evaporate water. And that's very often to be found. Also, even if we don't have the heat at a high temperature level, we could even run the thing under vacuum, and then we would always still get a very big advantage.
And can you give me a price for your solid oxide technology, reversible electrolyzer or fuel cell for a liter of hydrogen?
The liter of hydrogen or the cubic meter of hydrogen would be right now a little less or comparable to what we have with conventional technology. And I can give you some numbers, for example, on the installation of a stack, which would be in the fuel cell mode probably around something like 7,000 per kilowatt, 7,000 euro, which is about the state of the industry. And in electrolyzer mode, it depends, of course, on the efficiency. Our cells are very efficient, and that means we can probably create 3 times as much, or we can convert 3 times as much power to electrolyzer to hydrogen with the same machine.
Who wants more and who wants figures, please visit Mr. Berninghausen at his booth together with Energy Saxony. The booth of Sunfire is B44. It's next to the technical forum. It was a pleasure talking to you, Mr. Berninghausen. And I would like to invite you to go to his booth and also to stay here for the next interview with Guido Gummert, who's already waiting, CEO of Solid Power, about prices down, power generation up, fuel cells from the new player Solid Power. I would like to say thank you once again to Mr. Berninghausen, and thank you for your attention.